Happy Wednesday. I'll give everyone a minute here to get organized. Sorry for the late start here. The doctor's appointment took way longer than it should. I think everything in Ann Arbor just takes forever. So, just two things today, not too much happening. We're going to start our new chapter on classes, adding more tools to our toolkit on how we can solve problems. And there's not anything you can't solve without classes that you can solve with classes. Right? It's all going to work, but classes let us approach problems in a different manner, which is really fun. So we're able to start now looking at things and interacting with them in more of a human manner. So when we've worked with code before, right, we initially, like back in week 1, right, we started, here's a line of code, here's a line of code, here's a line of code, here's a line of code. Sure, it does some stuff, top to bottom, done. And then we started adding some branching, right, where we can have, hey, if I want to do something, or I might want to do something else, right, based on some conditions, make our code a little smarter, looked at some other types, we looked at more loops, right, so I can repeat, go to the top, and then we just talked about methods, right, I can take a chunk of code and put a nice name to it. I can make it repeatable. And if I'm doing the same thing over and over and over again, I can repeat that operation with my method, and I can break a big problem down into smaller problems, right? That functional decomposition we can do. So what we get to do with classes is we get to take that one step further. And what typically happens with classes is anything that is a noun when we're defining our problem could be a class. And I mentioned classes are a little bit more of a natural way for us to interact with problems in that we kind of understand what nouns are, right? If I say, hey, this is a phone, you know that it's not your phone, you know it's my phone. And you know my phone has certain attributes about it. You know my phone has a certain color, a certain make, a certain model, a certain operating system. It has a height, it has a width, it has all sorts of details. And every phone will have that same set of details, but it'll have its own set, right? So it makes whatever that instance of the phone unique. So when we deal with classes, we get to say, okay, I want a piece of code to represent some noun, some object, and it will have a bunch of attributes. So we can write code then to represent these objects, and they can have all the attributes, and then what we get is we get methods to interact with them, to do things, right? Like to make a phone call, I would take my phone and call, right? When it comes to writing classes, we write public methods that people can use. So we've used classes actually a whole bunch. The scanner thing we keep doing for getting input from the user is a class. It's part of the Java library, right? And we just say, hey, I want to use this pre-built thing here. And what we get to do is we get to interact with it in an abstract manner. Right? We don't actually know what scanner does or how it does it. All we know is that if we say next line, I get a string that the user typed in, everything they typed until they hit enter. I know if I use the weird next int, next doubles, I'll get some numeric values out. We can do a couple of cool things here, but it does what it advertises it does, and we don't need to know how it works. So one of the core ideas with object-oriented programming is that you can deal with things in an abstract manner. Right? We don't need to know the details to make this work. You tell me that you'll do something, and I'll just ask you to do it. So we can take these classes and we can build out functionality to solve problems, and then ideally it's reusable, right? The same idea with a method, right? You can use it more than once. If we write a class to do something, we could possibly use it more than once, right? There's a, not always the case, and for a lot of things that we're doing, we're not going to reuse our classes because they're solving very specific problems and we don't necessarily have other related problems. But the Java library is full of reusable classes, right? Other people have all sorts of classes and libraries you can use as well. So we're going to start off a new project here, and let's call this Chapter 7 Classes Morning. So I'll try and keep this separate from the evening group. I'm going to put it in the GitHub repository folder so that we'll be able to see all the code after. See if this will load up for us. All right, awesome. So the class we've used before, right, scanner, we say, hey, Java, I want to use one of these things that's from your scanner library. Right, so scanner, again, I like calling it keyboard, equals a new scanner. And then we give it system.in. So this new keyword is telling Java, hey, go load this thing in memory. Right, so I can use it. And then what I can do is I can say keyboard dot, and when I hit the dot here, it's going to show me, as soon as it's done scanning, come on, NetBeans. It's as bad as Windows. Oh, I got to add my import. That's right. Add my import. Thank you, NetBeans. Yep, type that for me. And then keyboard dot, and I get all of these public methods. These are things that scanner can do for me that I don't really need to know how they work. I just need to know it will do the thing. And again, we don't use a whole lot of them. We pretty much stick to next line because that's the most functional for us. But it has other methods. And notice we're using our instance of scanner that we called keyboard here, that we loaded into memory. If I say the scanner class dot, I don't get much. There's nothing here. Right? So scanner doesn't do anything by itself as a class. You need to create an instance of it and point it somewhere. In this case, system in. Right? You've worked with other classes before, like the integer class. We type integer dot. There we go. We get some methods. Right? We've done parse int. I don't think we've done a whole lot of other ones. Min, max are kind of interesting, sure. But these are things that the integer class knows how to do. And notice I don't need to have an instance of integer loaded in memory. I just say, hey, integer class, go do this thing. We'll get to that difference later, but it's important. So some classes have methods you can call directly for the class, and some classes you have to make instances. You have to create these objects, which is an instance of the scanner class. We'll call that an object in order to do things. But when we talk about object-oriented programming, right, we get to interact with classes in this abstract manner. So one of the fundamentals of object-oriented programming is abstraction. That you can deal with things in this abstract manner. You don't need to know all the details. Another core principle that kind of goes along with abstraction is called encapsulation. That's another fancy term. And all that's saying is we're going to take all of the details, all the things about this noun, we're going to build it into the class, we're going to put it into one nice little package. And then what we're going to do is we're going to hide away all the details. So you don't need to know what things I'm storing. Right? All you need to know are the public methods that you can interact with my class. I'm going to take all those details, package them up into a nice little package, which we call a class, and we're going to put them there. So to make your own class, now Java is very particular about this. So we have this public class chapter 7 classes morning thing here. Right? And this name of the class matches the name of the file, letter for letter. You've probably noticed. Right, chapter 7 classes morning. So it looks like we've got a dot in here. That's our, oh, I'm not in there yet. Here we go. That's the package name. Here's the class name. Chapter 7 classes morning, letter for letter, case for case. Our Java file matches the public class. So Java actually enforces a rule. You can only have one public class per file. I'm fond of it. Other people get driven nuts by it. But so if you want to make a new class, we need a new Java file. So we come over to our package over here in the top left. So you got the project, you've got source packages, and then you have the main package, which is the name that we typed in. So I'm going to go right click that and say new Java class. And we'll call this, we'll do rectangle. It's a nice fun example. It's easy. So I'm going to make a class for rectangle. Now class names should start with a capital letter and then follow that camel casing pattern. So like scanner was a capital S, the integer class, capital I. What other ones do we do? We did random, right? So random, we talk about random numbers, right? Random, capital R, random. So classes will start with capital letters here. It's the convention. Again, it's not necessarily has to, but you just should, because that's the pattern to follow. So when it comes to a class, right, we've got our public class rectangle, a set of curly braces. Notice there's no main method here. There's no public static void main string args. So a class itself is not meant to be run. When we're building out classes here, right? The very first one here is meant to be run. The one with main method. You only need one main method. And actually, if you have more than one, Java is going to be really confused. because it's not going to know where to start. When Java goes to run your program, it looks for the file that has the main method in it, and it starts there, behind the scenes. So it's really good at that. So if we try and put a main method in another class, it's going to get confused easy. But we don't need a main method, right? We just want to do the details of rectangle. Now with this idea of encapsulation, we want to take all of our details, package them up in a nice one little spot here. We don't want to give people access to the behind the scenes details. So essentially that means all of my attributes, I want people not to be able to touch. I want to make all those private. So before, when we did our little shell example, let me see if I can find that one here real quick. Our Project 2 morning shell. We looked at, hey, you can add public static int variables. You can add class level variables that are accessible anywhere in the class. It's essentially the same thing, but we don't want them to be public. So when I'm talking about a rectangle, I'm going to say, okay, all rectangles will have these attributes. So I'm going to say they're private. So we say private, and then the type here. So we're going to have probably an int for length, and we're going to have a private int for width, and maybe we'll have a private string for color. Notice there's also no static word here. We'll get to static after we've done this one first. So this means every rectangle that you create and load into memory will have its own length, its own width, and its own color. Okay, well, if all of these are private, how do we get at them? Well, we need to write public methods now. So we're going to write get methods for getting the values, and we're going to write set methods for setting the values. Getters and setters, or sometimes people call them accessors and mutators for accessing or changing, mutating the value. I don't know who's fond of that. I prefer set and get. They're just easier to say. So if the method is meant to be used by other people, we're going to say it's public. We're going to say, okay, other people can use this method when they have a rectangle. So we'll have a public, and then there's two types of methods. Remember, there's void methods, and there's value returning methods. So anything that's a get method is going to return a value, right? So I'm going to say this is an int type of method here. We'll call it get length. So just like we can write methods in our classes, again, we're losing the static thing. We'll come back to that later. We'll say, okay, get length, doesn't need any arguments. I got my set of curly braces, and I'm going to return length. Here's my value for length. Go for it. Then we're going to write a public int get width. We'll return width. And a public string for get color. And we'll return the color. So we have ways to get all of these values from a rectangle. We don't have a way to set them yet. So now we need to add some set methods. So set methods are typically void. They don't need to return any value. Like you're giving it the value to set here. So a set method is public void set length. And then if you want to set the length, you need to give me an argument of what length do you want to set it to. So we'll say int length. So if you give me a length when you call the method set length, I can set my length to the length you gave me. Now there's a little problem here. If you say length equals length, you notice they're both orange, right? Orange is the argument length. I now have a class level variable here and an argument here with the same name. That's technically called shadowing. So we've kind of hidden this one behind the shadow of this one. To get at your class level variable, we're going to use a new keyword. We're going to say this. So this is a special keyword that means the current instance of this class. So when we call keyboard, and we want to use our instance of scanner, we say keyboard.nextLine. Keyboard is the instance of scanner that we're using to call the nextLine method. So with my rectangle, if I call set length, I have to create a rectangle first in memory, and whatever rectangle variable I have, that is the current instance. And this is what's going to differentiate it. So I might have a rectangle, you might have a rectangle, we might have 7 different rectangles. We can make as many objects in memory as we want from our class. So when we call set length, this is saying, okay, the current instance length. And now you'll notice it turned green to match my green. Right? We can see, okay, now this is the class level variable equals the argument. And we're going to do the same for set width. For width, and we'll set this width equals the width. And one more for color. set color, given a string for color. This dot color equals the color. Now, some people are irritated by having to type this. Sure, it's like 5 more keystrokes. This dot, okay, that's a little bit more typing. So what they're tempted to do, instead of saying length, they'll just say L. And then we can just say length equals L. Now, this is really ugly, right? Short variable names are bad because they're meaningless. So if I come over to my code here, that actually has a main method, the thing that's going to run, let me make a rectangle, right? So we always start with the type, right? What type is it? Is it an integer? Is it a double? Is it a scanner? Is it a random? Whatever it is. Hey, it's a rectangle, right? Rectangle is the class name. It's the type name. So I want a rectangle. I'm going to call it, I don't know, my rectangle equals, and we're going to use this new keyword that tells Java, hey, load one of these things in memory. Make a new instance of this class for me here. New rectangle. And then a set of parentheses. Now we have a myRectangle instance of the rectangle class that we can reference, so we can ask for. So if we say myRectangle, and we say dot, notice there's a whole bunch of stuff here we didn't write, but ignore that for now. Next chapter, it'll make a little bit more sense. The stuff that's kind of bolded, get color, get length, get width, set color, set length, set width, those are the ones we wrote. Those are the ones we're going to use. The other ones we're going to ignore. But you'll see set color says string color, set width says int width, set length says int L. Right? The variable name you use is going to show up in this suggestion, type ahead, autosense, IntelliSense, whatever it's called here. So using good variable names will show up when you're using your class later. So you really want to make sure you've got good variable names. I think I can just undo. Yep, let me just undo. There we go. So if I come back to my rectangle, dot, and now it says, okay, set length, you give it an int for length. Sure. So how about we ask the user, right? We could do that. So we'll say, you need to enter the length for your rectangle. And then we can have an int for length equals an integer.parseInt of the keyboard next line. Cool. And we'll ask the same for width. Enter the width for your rectangle. We'll have an int for width. And then one more, how about color? Enter the color for your rectangle. That's just a string for color. And then there's no integer parseInt here, right? It's just a string, so we can take just the next line. Okay, so we'll ask the user for a couple things. We'll make that rectangle. Java's going to load that rectangle into memory. And then we can go set some values. So we can say myRectangle.setLength, given the length, myRectangle.setWidth, given the width. Now, if you're not getting these type ahead suggestions, I know a couple of people had a little bit of trouble with their settings. You go to Tools and Options, and you go to Editor, and you go to the Code Completion tab, and then you pick the Java language. It's like 7 levels deep in here, but you'll get there. There's 3 checkboxes up top. Usually the first one's there, but then you want the next 2 for auto pop-up and subword completion. You turn those on, and you should get all the auto suggestion stuff that works there, so you don't have to do more typing. Right, and we'll go back to my rectangle, and we want to set color, and given the color. Okay, so we're going to set all those values for that instance. Right, I can also make another rectangle if I wanted. So I could make, let's call this other rectangle. And other rectangle, let's not ask the user, we'll just set the length to like 10, oops. Set length to, I don't know, we'll do 10. And then other rectangle dot set width. We'll set maybe to 5, and then other rectangle dot set color. What color should we set this one to? Green, you got it. Set color to green. Sure, maybe lowercase g, I don't know. So we can ask the user to give us values, or we can just hard code those values in. We can give them literals. Right? Either way, rectangle doesn't care. Rectangle says, okay, if you want to set my length, give me an integer, please. That's all the method does. Hey, give me an integer, please. Give me a width, please. Right? Give me a color. It'll take anything we give it. Now, all by itself, just a bunch of set and get methods are kind of boring. There's no functionality here. It doesn't really do anything. But now we can start adding some features. Right? If we know what the length and width are, and you think back to, I don't even remember what year math class this is, you know how to calculate the area of a rectangle. Sure, we can do that. So I'm just gonna put it at the bottom. Some people get weird about the order in which you put methods in. I like all the gets to be together, all the sets to be together. Some people like gets and sets for the same variables to be next to each other. I don't really care. I'll try and put all the gets together just because it makes me happy, but yeah, it doesn't matter. So we'll say, hey, a public int, we'll say get area. We can calculate area. We're going to return, or let's say an int for area is equal to length times width. Take the current length times the current width, save that as area, and then we can return area. So if you want to, you can also save one line of code. You can just say return length times width. You don't need to save it as a variable first, but there's nothing wrong with it if you want to save the variable first. You're not really hurting anything at all. It's no big deal. You'll calculate it, save it, and then we'll return the value. So we can say, okay, hey, the area of your rectangle is, so we'll say the area of your rectangle is, and we're going to add in here my rectangle dot get area. So whatever value this returns, whatever integer that returns, we're just going to append right in here to this string. Well, we can do the same with the other rectangle. The area of the other rectangle is, and let me bump this down, it's getting a little long there, I'm sorry. So now we want the other rectangle dot get area. Remember, whatever instance you're using, that's its values you're going to get. So when you ask for get area, it's going to say, okay, what's the value of that my rectangle's length and that my rectangle's width? Those are separate from the other rectangle, right? And we can have 20, 30, 40, 50 of these rectangles in memory. Each one will get its own location in memory for storing its length, its width, and its color. So let's give it a run, make sure it works, right? All right, so enter the length. How about 10? Oh no, let's do something different than that, right? So how about 7 and the width of 4 and blue, right? So our rectangle, 7 times 4, 28. The hard-coded one, 10 times 5, 50. Right? Area is great. No big deal. And what about perimeter? Could we do perimeter? Yeah, that's not too bad, right? So we'll go to the rectangle class. We'll have a public int get perimeter. Perimeter, right? Perimeter. So we can calculate that, right? We can do it on a single line or we can do it in 2 lines, doesn't matter. So we'll have a perimeter is equal to length times 2 plus width times 2. And we can return the perimeter, right? Now we can calculate the perimeter. So classes can start to have additional functionality. We can add more interesting things to them. Now this one, again, is still kind of boring. It doesn't do a whole lot here, but you know, we can do some math. I can't recall other mathy things you do with rectangles other than area and perimeter. Sure. So we got our class, and we can make as many rectangles as we want, load them into memory, and each one will store its values. So these are instance attributes or instance variables. Right? Each instance will get its own because they're not marked as static. Static is a different animal we'll look at after you do another one of these examples. And the methods then interact with the instance variables. They have access to the instance variables. They're defined at the class level. Right? So anywhere in the class, I can access these variables, which is great. Like for getting area, getting perimeter, I can get the values out. So let's run it in debug mode. Let's watch this happen. So let me just pause it here at like line 19. I'm going to come to 19, click on the line number, put the big red dot in. I'm going to run with debug mode instead of just a regular run, because we want to watch this happen. It's really cool. So let's see. We're probably in our output. Yeah, we're probably waiting for. Yep. Okay. Enter the length. Sure. So let's do 7 again, and 4 for the width, and red for the color. Great. Okay. Now we got to line 19 and we're waiting. We have not ran set length yet. But we can see I've got a keyboard object, I've got a length variable, I've got a width variable, I've got a color variable, and I've got a my rectangle, which is type of rectangle. Now, you probably never opened keyboard before, but like there's a bunch of stuff in here that makes no sense. So it's not very interesting to open. But if you open up the my rectangle, you'll see there's a length, a width, and a color. It's saying, okay, this variable stores values for length, width, and color. And we can see right now it's 0, 0, and null. Null is actually really bad, and we'll learn how to fix that a little bit later. But we're going to assign it a value anyways. We're not too concerned. Just keep in your back pocket that nulls are bad. It's a special keyword. It doesn't even mean like 0 or empty. It literally means non-existent. It's not there. So instead of stepping over, I'm going to use the step into button because I want to go into the set length method. So I jump into set length and all of that stuff went away because I don't have access to them. What I have access to now is I'm in the rectangle class and I can see this. This is my current instance. So I'm going to see this length, width, and color, 0, 0, null. Those are my current values. And I see the length argument is 7. Sorry, that's real tiny. I got to figure out the zoom thing. I think it worked for somebody, but maybe I clicked the wrong buttons. So we'll see, okay, we're going to set length to length. So if I step, we now see this length was set to length. I have 7 and 7. That's what we expected to have happen. Right, so if we open up my rectangle, we can see now length is 7. We set it to 7. I'm going to step over, so set width happens. Now width is 4. I'm going to step over. Now set color happens. Now color is red. Right, we could step into if we wanted and watch it go into the method, but we saw it once. I don't know if you need to see it again. We'll make another rectangle. So now in my variables list, I have other rectangle with 0, 0, and null. Right, so we get default values. So anything that is numeric gets set to 0. Anything that is a reference type or a class that's not a primitive type is set to null for defaults. So the defaults are kind of bad. So we'll learn to fix that in just a little while. But we'll see now I've got 2 different rectangles in 2 different locations in memory. I don't know where in memory, but they're somewhere out there, each with their own set of values. And we can set them 10, 5, and green. And now we've got 10, 5, and green, and we're good to go. I'm just going to hit continue, let it finish running. We can take a look at the output and see, yep, 28 and 50 again. So that's rectangle. Some other cool things we can do, right? This idea that we're going to encapsulate a class. We're going to take all the details, put them together in one nice little package, also means that my class is responsible for making sure it maintains its integrity. Now, I don't know a whole lot about math, but I'm pretty sure you can't have a negative length of a rectangle, right? That's just an invalid value. So when you call set length, we can do some sanity checking. We can do some validation on it. We can say, okay, if the length is greater than 0, great, let's go set it. If you give me something that's not greater than 0, I don't know, what should we set this length to? Maybe set it to 0? Like that was our default. Maybe we just stay at the default value. So if you give me something that is good, right, and I can use any sort of definition, any sort of check here, any sort of relational operators, logical operators, whatever we define good as, to say, okay, if it's a valid value, accept it. If it's not, we'll put you back to default, right? That's no good. Go away. So we're going to protect the integrity of our class to make sure that you can't give me bad values. Now, these values are private. No one can get at them directly. The only way they get at them is through my public methods. So no one can now set the length of rectangle to a negative value. It's impossible. Right? We're protecting the integrity of our class. We're making sure that you can't put my class in a bad state. We'll do the same for width. So we're going to check for width. Now we need width though. Width is greater than 0. Set this width to the width. Otherwise, set width back to 0. Right? Keep the default if it's no good. All right, so we're happy with width. Now for color, I don't really know how to sanity check that. I mean, we could say like if color is red, or color is blue, or color is green, or color, like have a big if, else if, else if, else if, else if, else if, else if. That sounds crazy, right? And then someone's going to come up with a new color because the people at Crayola are bored or something, and they have new colors all the time. And it's not going to be in our list. So it's probably not feasible to have some sort of validation for set color. So we can just take their string, right? And I'll assume you're probably going to give me a color, right? Midnight blue, sure. I didn't know that was a color before, but it is now. Right? Okay, we'll just take it. So again, you can't really validate everything if it doesn't make sense. Or if we wanted to be like, hey, let's make the Model T, we could say, okay, you can have it any color you want as long as that color is black, right? We could check, hey, does string color equal black? If not, it's black, right? We could be like Mr. Ford. You know that story, right? Or am I that old now? The Model T story? Really? Okay. That's all right. That's all right. It's just Michigan history, you know. No big deal. All right, so we can additionally then maintain the integrity of our class by, if you're going to set a value, I'm going to make sure it's good. Right? Life is good. We like that. Okay? The next thing we get to do is we can avoid this ugly null by writing a special method. So when we make an instance of the method here, or make an instance of the class, we're saying, hey, make me a new rectangle, please. We're actually calling a special method called a constructor. The constructor's job is to construct the object, to load it in memory. So if you don't write a constructor, Java gives one to you, right? And it sets all the numeric values to 0. It sets all your classes or reference types to null, right? That's what it does for you. That's its default, because it doesn't know any better, but it's going to try, because you need a constructor to set values for your variables, for all of your instance attributes. Right? All these instance variables, all these instance attributes, they need values. If we want to write our own constructor, we can do that. To do that, it's public, and then it's the name of the class. There is no void or return type, and that's how Java knows it's a constructor. So public rectangle, set of parentheses. So this is our constructor method. Constructor method. Its job is to construct the class in memory. Give all the attributes values, right? So we want to explicitly give them default values. So I can say, hey, length equals 0, width equals 0, and color equals an empty string. An empty string is not null. It's just there's no characters inside of it. It is a string, so it's a valid string. You're not going to run into null. Now, okay, so before we'll take one step back here. Let me comment this out. Where is it? Comment. Toggle comment, control / there we go. So do you remember one of the things we could do with strings is like you could find out how many characters are inside of it? So if we make a rectangle and then we have a myRectangle color equals the myRectangle.getColor, get color. Okay, and then I can say myRectangle color, myRectangle color. Oops, I have to tell it what type that is. That's a string here. So then we can say myRectangle color dot length. MyRectangle color. Remember, dot length will tell you how long a string is, how many characters are inside the string. Pretty sure we talked about that. So we could say, okay, so the, I don't know, well, your rectangle has, I don't know, the length characters in it. Sure. Length plus characters in its color. Okay, so I can ask for the color, right? The get color here, stored as a string, and then any string we can get the length of. Right? We can find out how many characters are in it. Not the most interesting thing, but it's kind of fun. So let's give that a run. So length, we'll do 10 and 20, and blue. Oh, it didn't run the latest. This compile on save thing kills me. Like, I don't know what I did different here. I think it's been working the whole time up until now. Try one more time. All right, so 10 and 20 in blue. Oh, crash. So we crashed at our Chapter 7 classes morning, line 22. We got a null pointer exception. Cannot invoke string length because my rectangle color is null. Nulls do bad things to programs, like crash them, right? Java had no way of knowing that color didn't actually have a value and it was going to give me back null. So nulls are dangerous and likely to crash programs. They're pretty bad. So to avoid that, then, we can add a constructor that sets default values. Even if the default value is an empty string is not null, right? An empty string exists, it is a string, it just has no characters inside of it. So now if we run it, we're going to get 10, 20 in red. We get the rectangle has 0 characters in its color because we hadn't set the color yet, right? We only had the default. So we created the instance, we got the default values. So you can actually, in debug mode, you can step into the constructor here. So let's run this in debug mode again. Now that we wrote a constructor, we can step into it. Right? Before there was the default constructor, there's nothing to step and see. There was no code there behind the scenes. It's kind of sad. But now we get, okay, I'm about to call the constructor. I'm here at line 18. I'm going to step into, and we go to the constructor method. We say, okay, length, width, and color. Right, 0, 0. I mean, the zeros don't change, but again, it's better to be explicit. You want to give your attributes default values explicitly. Don't rely on them initializing to 0. Right. Technically, you don't have to, but again, it's just always better. Let's just be deliberate about, okay, my constructor will set all of the attributes here. And then we're going to go from null to an empty string. Now it's a type of string. Now we have a string there. Right, and then it finishes up, and we're good to go. So that's the rectangle class. Right? And again, when we talk about classes, right, we understand a rectangle is a noun, it's a thing. They don't necessarily have to be nouns, but most of the time our classes will be nouns. Most of the time. Each instance gets its own set of values loaded in memory. So, for this one, oh, I touched the cord. I touched my cord. Hang on, I just have to wiggle it. Shut up for a second. There it goes. All right, we're back on the projector. For this example, not all that interesting, right? But we'll do another example in just a minute where it'll make a lot more sense that you want to be able to have multiple of these classes loaded in memory, multiple of these objects. So again, the terms are a little funny and technical. The class is the definition, sort of the blueprint for how you build an object and what it does. An object is when you create an instance of that class. So we say, okay, hey, I want a new one of that class. This is now an object. So it's an instance of the class. Right? I've created one, I've instantiated it. It's a single instance that sets its own set of values, and we're good to go with it. So you can still do all these rectangle things without a rectangle class. Right? We haven't added any new functionality here. We've put a name to what it is, and we've got methods, so we broke down problems into smaller and smaller and smaller problems. I mean, area and perimeter are not the most interesting problems to solve, but sure, we broke it down into two different methods at least. And then we can reuse it if we want. Okay, just without having to copy paste, it's a little bit more reusable. So still getting kind of those same benefits, right? When you're dealing with methods, we said, hey, we can put a name to what we're doing. We can reuse it if we want to, and it helps us break big problems down into smaller problems, right? That all is the same with classes. So classes will take advantage of all those things. It will have its attributes, and it will have methods that belong to it. But it's in that same vein, that same idea. It's just going to help us approach problems differently. All right. Before we go to the next example, why don't we take a couple-minute break? Can we just do like a 5-minute break real quick? I'm going to make a quick pit stop, and then we'll pick it back up with some more class examples. And then we've got 2 more topics after that we'll probably save for Monday. So come Monday, we need to talk about the solution to Project 2. Right? We'll have some time to work on that today. And then we'll finish up the Chapter 7 classes, and then we'll talk about the next project we're going to work on. So we'll got definitely a little bit more to talk about today with classes. We'll do some more examples, have some fun with it. We'll wrap it up on Monday, and then I'll post the quiz. I think I have all the quizzes out. I forgot to post one of the quizzes last time, right? So I think we added a couple extra days. So if you look for 4 and 5, I put them out to the 14th. Because usually we're going to be due Mondays, but I screwed up. So I said, okay, just take like 3 extra days on both of them because I doubled up on you by mistake. So don't forget to take those. Looks like no one has done yet, but that's okay. Like, there's not a giant rush. If you want another day or two past the 14th, that's fine. I can take it a little after that too. But ideally, you're like keeping up with the reading and kind of doing the quizzes, or like you pop open the quiz and you read all the questions real quick, and then as you're reading through the chapter, you're like, oh, okay, here's the answer to that one. Here's the answer to that one. So just to help you to kind of like be a little more focused when you're doing your reading, you kind of pay attention more if you know you're looking for certain things. All right, so why don't we take 5? I'll be back in just a minute and put on my break time here. Nope, that's the starting soon. I did the wrong one. That puts us at, what, 11 a.m.? You just take 5 minutes, and I'll be right back. Alrighty, let's flip on back here, cut the music, and let's take a look at another example. So let's build another class here. But actually before we write the class, let me show you this cool thing called a UML Class Diagram. I think we talked about UML just a little bit, trying to draw the flow of, hey, here's a decision point. Do I do this, or do I do this, or do I loop? Do I come back here? That sort of thing. So UML is great. It has all sorts of interesting notations. One of them for a class diagram is pretty easy. It is a big rectangle here with 3 sections. The top section is the name of the class. So class name. The middle section is the attributes. And the bottom section is the methods. Okay, a couple other notations we're going to add. You get a dash for private. You get a plus for public. Now, Word is not a great tool for doing this, but it works, and almost everyone has Word or like Google Docs or something similar. Right? You don't need a fancy tool like Visio to draw UML class diagrams. There's actually a couple online tools that are pretty decent too, but they kind of spam me with their ads sometimes. So I prefer Word, and my favorite way to do it is I just pick a spot and I go to Insert a Table and I make a 3x1 table. So we're going to write a class for bank account. That's our class name. This will represent a bank account. So what attributes do you think a bank account has?
Balance.
A balance, okay. So now UML's funny. So minus for private. I'm going to say balance, and then UML says you do this backwards. So we say balance colon what type it is. So it's probably a double, right? You probably care about the pennies in your account. It's probably not an integer value. Okay, so we got a balance. What other attributes do you think a bank account might have? Yeah, a list of transactions. So we don't know how to make a list of transactions yet, so can we punt on that one? But I like that idea. We probably are tracking our transactions somewhere. Yeah. Do you think we know who owns it? Right, the owner. The banks are really curious to know who owns the accounts, and the IRS is as well, given the new regulations coming through, where all transactions of $600 or more are going to get reported to ensure everyone's paying their taxes. I mean, they're doing it already for transactions of 10,000 and more, so they're just kind of ratcheting it down kind of a lot here to try and pick up on fraudulent activities, perhaps. So just a pro tip, by the way, tax avoidance is legal. Tax evasion is illegal. Okay, there's a big difference there, and that's why big corporate companies have large tax departments that actually make them money in tax savings because they're avoiding taxes. They're not evading them, they're avoiding them. Perfectly legal because our system sucks. All right, so we got a balance, we got an owner. Is there anything else we might know about a bank account? Do you think it has like a number as well, like to identify it? Yeah, type. Okay, yeah, we could have a type for maybe as a string. Sure, and then how about a number? Yeah, maybe as an integer, but those are kind of long usually. What are they, 9 digits long? So yeah, we could fit, that's 999 million. We could fit that as an integer. We'll do an int. Sometimes you want to store that as a string, just because it can hold a larger value, but it's probably fine here for number. Sure. All right, so then that's all of our attributes. Again, we could probably come up with more, but this is a good start here. What methods are we going to have? So we need get methods for everything, right? I need a way to get balance. And now you say the return type here. So the method colon the return type will return a double, and then a get owner, which will return a string, and a get type, which will return a string, and a get number, which will return an int, and then sets, right? Well, which one of these do we actually want to be able to set? So just because you have an attribute doesn't mean you need a set method for it. If it doesn't make sense with your object, don't let it have a set method, right? Like once you have an account number, you probably can't change the account number, right? Because I think that would make bad things happen in the history. So we don't need a set number method, right? We're gonna have a number and we're just gonna leave it there. Type, probably the same thing, or maybe you can convert an account from a checking to savings, but I'm pretty sure they'd probably leave it alone. Maybe you could change the owner, right? Maybe say, okay, or like if you change your name, maybe, then we might change the owner's name. Again, this is probably going to be like related to your social security number in real life, but we'll just pretend it's a name for now, and names are changeable. Technically, you can change your social security number too. Like if you get identity theft and things, you can go through the lovely process of getting that changed. I don't recommend it. It sounds terrible. So maybe set owner then. So we'll say I want a method for set owner, and then in the parentheses, again, we're still doing it backwards. We're going to say owner :string. And then what do we return? With the set method, we usually return void. Like there's no returns. It doesn't do anything. So it's instead of type variable name, it's variable name : type, because UML sucks. I don't know why. But you get used to it after a while. It's not too bad. So we have a set owner. Do we have a set balance method? Can you walk up to the bank and say, hey, set my balance to $10,000, please? No. How do we interact with an account? Yeah, so you can deposit money or you could withdraw money. So we're going to make methods for deposit and withdraw. Deposit an amount as a double. And deposit probably doesn't need to return anything here. That's void. And then withdraw. Withdraw, given an amount. That's a double. Now, this one here, I think we actually do want to return something. Right? If you walk up to the bank and you say, hey, I'd like to take out $10,000 out of my account, please, they're probably going to tell you no, like, unless you guys have a lot of money in your bank. Right? So they might give you an answer back. So when you ask to withdraw, they might say yes or no. So a yes or no is essentially a Boolean, right? So maybe this will be a type of Boolean, and we can say, okay, yes, you successfully withdrew the money, or no, you didn't have enough money. Go away, or try again, right? So again, it doesn't necessarily have to, but I think that's going to fit well for what we're going to do with our example, right? Okay, sure. All right, so I think that's the ways that we're going to interact with bank account. I think that works out pretty well. So let's come back and we're going to go to our package here, right-click, new Java class. We'll call this bank account. Okay. Now, the fine folks who write NetBeans are also developers, right? They write NetBeans, they develop NetBeans, and they're lazy too. And they know the people who use NetBeans are lazy, because all good developers are lazy, in a nice way, in that we want to be efficient. So I'm going to list my variables here first, my attributes. So I have a private double for balance. I have a private string for owner. Oops, semicolon there. I have a private string for type, and I have a private int for number, right? Those are the attributes that we said we had. Again, we want them to be private, and we'll make public methods if you should have access to them, okay? Now, again, the fine folks in NetBeans know us developers are lazy, and it's kind of a big pain to type out a bunch of get methods, right? And you can imagine if you had more attributes, right? If we had more things here, and more things and more things, typing out a bunch of get methods would suck. Well, it turns out there's a solution for that. So in your class here, you right-click, and there's this lovely insert code option here. Click on insert code, and it says, hey, what do you want? Constructors, loggers, getters, setters, getters and setters, equals, hashcode, toString, delegates, overrides, add property. Most of that doesn't make any sense right now, but let's do some getters, right? I want getters. Which fields do we want getters for? I want all of them. Check in the top box. Generate. It writes the get methods for us. Right? NetBeans is fantastic. I mean, any good IDE is fantastic. It's going to do stuff like this for you. It's super easy. Now, you can also insert setters. But like we talked about, it doesn't really make sense to set most of these values. So we'll do it for owner, though. So I'm going to right-click, insert code. I want a setter, and I want just for owner. I'm just going to check the owner box here and say generate. Now we can change the owner. And it even gives you the correct notation. This.owner equals the owner argument. Look at that. It's smart enough. And again, this is another reason I prefer this format. Right? This is just the convention. Okay, so we've got gets and sets already. Now, if there's no set method for type and no set method for number, how do we give them a value? Are we missing anything else for our class here? What other method have we not written yet? How about the constructor? So in our constructor, which fields do we want? Well, I want number and I want type. Maybe owner too. It doesn't have to be here. I'm going to not ask for balance though. I mean, I guess it depends on your bank. So our bank is going to say, okay, we'll make a new account. You have $0. You can go deposit some. Other banks will say, we're not opening the account for you unless you pony up $100 of cash, right? And let it sit in the account or something like that. So maybe you need a balance. But for now, we're going to say no. So I'll say generate, and I get, hey, look at this. A string for owner, a string for type, and an int for number, and I'll set my values. If you're only ever setting the values in the constructor and you're not ever changing them again, you get these nice little warnings over here. It says, hey, this field could be final. Remember way back we did a final value for like pi, and we put it in all uppercase and with underscores. And we said final means you can set it one time and then the code will not let you change it again. So if NetBeans sees that you're never changing it again, it's going to suggest, hey, you might want to make this thing final just to keep yourself from shooting yourself in the foot. Like if you accidentally change it later and you didn't mean for it to be changeable. Right? Maybe we can mark it final. We're not going to worry about that. You can play with that a little bit more in the next course if you continue on and take object-oriented programming. Look at some of that stuff. So just ignore those helpful suggestions here. Yes, it's fine. And if you want to do it, go for it. But again, we're not really going to get into that too much here. We're going to say, essentially, if you can only give the value in the constructor, it's read-only. Right? It's a set once and forget it. You can't change it, which is probably good for type. Right? And for number, we don't want to change any of those, right? You don't change your account number, don't change your account type. If you want a different one, go make a new account, right? Withdraw all the money, deposit in the new one. That'll keep our ledger nice and happy, right? Although maybe you could withdraw the money $500 at a time to put it into the new account. All right, sorry. All right, so we've got our constructor then that accepts some values. So now I can make a bank account and I can get and set, but I'm still missing my deposit and withdraw. Okay, so let's do deposit and withdraw. Again, up, top, bottom, I don't really care. It doesn't matter too much. We say public void deposit for a double amount. We take our balance and we add the amount. Right? Good. The bank will always let you put more money in. Can pretty much guarantee that. Right? There's no like, hey, they're going to tell you no, check here. I mean, I guess if they're looking for like counterfeit bills and you give them a counterfeit bill, but that's probably another story here. So we'll have our deposit. Now we could still do some sanity checking, right? We could say, hey, if amount is greater than 0, let's do this thing. Right? Because if you give me a negative value to deposit, that's actually a withdraw. And we've screwed up your balance, right? We might be losing integrity if I accept the negative value here, right? We only want positive values for deposit, right? Okay, so we'll add more money with deposit, and then we'll do withdraw. So public, now this one we said was going to return a Boolean, a true or false, whether or not it was going to work. And we'll call this withdraw, given a double for amount. Now again, probably the same sanity check, right? Let's make sure the amount is greater than 0, and then instead of adding it, we want to subtract it, except that if it's more than your balance, we don't want to do that either, right? So if it's, let's check this then. How about if it's less than 0 or the amount is greater than the balance, then instead of doing something, we're just going to return false. Right, this Boolean. Hey, you gave me a bad value, or you asked for more money than you have. I'm going to tell you, no, go away. Return false. Right? Because this one we said is going to tell you, yes or no, it worked here. So if it was less than 0, right, don't withdraw negative because that's a deposit, right? Or if you ask for more money than you have, we'll just return false. So if we did not return false, right, then this next line of code will run. So the else is redundant at that point. Because if this was true, the method stopped, right? As soon as you hit a return, the method's done. Nothing underneath it's going to run. So I don't need an else block. Because if it was true, the method will stop. And if it's not true, then I still want this code to run anyway. So then we can take our balance minus equal the amount, and then we can return true. Say, hey, it worked. Right? So if it was no good, don't do it. Tell them false. Otherwise, withdraw the money. Tell them, yes, it worked. True. That's our withdrawal method. Should we try it? Okay, let's give it a shot. So I'm going to bump all this other stuff down a little bit here, right? And we'll put our bank account up here. So bank account, we'll call this, I don't know, account equals a new bank account. Now, this constructor takes arguments, right? That's perfectly fine. You can have a constructor that takes arguments, just like any other method. You can say, okay, if you want to call the constructor, you have to give me owner, type, and number, right? So this bank account with empty parentheses doesn't work. If you write a constructor, the automatically provided for you Java default constructor that sets everything to zeros and nulls goes away. That default constructor only exists if you don't have a constructor in the class. Right? So because we wrote one, we don't get the default. So there is no option to make a bank account unless you give it a string for owner, a string for type, and an int for number. Okay? So sure, I don't know, we'll say Eric is the owner, we'll say this is a checking account, and the account number 123456. Sure. Right, and then I can interact with the account dot, and now I get balance, get number, get owner, get type, set owner, withdraw, and deposit. Oh, deposit was at the top. So I probably want to put money in, right? So let's deposit $100, and then let's try and take some money out. So how about we ask the user here? We'll ask how much money to take out. How much money do you want to take out? And we'll get an int for an amount, is the integer parse int of the keyboard.next line. And then we'll try it. But now I need to know what the result is, right? So I can say, hey, if account.withdraw, given the amount, right? This here is a Boolean expression, right? Account.withdraw of a given amount will return a true or false. I can put it right inside an if block, right? I can write a method that returns a true or false, and it can go inside an if block because it's going to return a true or false value. So if it worked, we'll say, great. Okay, you withdrew, right? Withdrawed? No, it's definitely not withdrawed. That sounds wrong. Withdrew. It just sounds funny. Withdrew the money. Else, so if it was not true, if we got back false, say the bank says no. Sure. Right, can we try it? So we know we've got $100 in there, right? We deposited 100. So how much money do you want to take out? 50? Okay, we withdrew the money. Right, let's stop and try again. How much money do you want to take out? 700? The bank says no. Right, we don't have 700. We only put 100 in there. We should be able to take out all 100 though, right, and have a zero balance. Right? Okay, we withdrew the money. Great. So how about we do some other silly stuff with this? How about we make a loop? And let's do this. We'll say string for, I don't know, again, I don't know, more, do more things equals y. And we'll say while do more things dot equals ignore case, equals ignoring case. If it equals a y, then let's go do some stuff with our account. So we can ask the user, hey, do you want to deposit or withdraw? I guess, right? So we can have a string for deposit or withdraw is the keyboard.next line. We should probably ask them first, right? Next line. Do you want to deposit or withdraw? Again, sort of like I'm capitalizing them. Hopefully that's a clue for them that they should enter deposit or withdraw, right? We'll get the line. And then if deposit or withdraw dot equals ignore case, if it equals deposit, then we should ask them how much they want to deposit, right? Get that amount. How much money do you want to deposit? Get the amount, call account.deposit, given the amount, right? That'll always work. And then if it wasn't deposit, how about else if it equals withdraw? right? Withdraw. Then we'll ask them, all right, how much do you want to withdraw? We'll try and withdraw the money. And again, we can like still do this sort of check here. It's getting a little long here. So ask for the amount. When do you want to withdraw? Deposit out, withdraw. You don't need the word out, right? It's just withdraw. Get the integer value, try and withdraw it. And then at the end of that, right, we might also then say, hey, if it's not deposit, it is not withdraw, tell them please enter deposit or withdraw. Right, that's the sort of error message. Sure, we can do that. That ends that curly brace. And then at the end of the loop, we could print out your current balance, maybe. Current balance would be account.getBalance. And again, you could do the nice number formatter, currency formatter stuff. I'm assuming you could work that out and wouldn't have too much trouble with that. I think we did an example a little while back. Okay, and then we need to make sure our loop is not infinite. We should ask them, do you want to do more things? Right? Is keyboard.nextLine. Line. You want to, I don't know, have more transactions, do more transactions? Do you have more transactions? Yes/no. Like, hey, tell me yes or no. Oh no, y/n, right? We were just looking for y. Sure. So we'll keep them in a loop. Let's try it. So now we can interact with our bank account kind of as much as we want until we get bored, which is probably pretty quick. It doesn't do a whole lot. Okay, should we deposit or withdraw? How about ASDF? Please enter deposit or withdraw. Current balance is 0. Do you have more transactions? Yes. Deposit or withdraw? Should probably deposit something first, right? How much should we deposit? 1,000. All right. Okay, current balance is 1,000. Do we have more transactions? Yes. Should we withdraw some money? Let's withdraw 500. Okay, we withdrew the money. Current balance is 500. Great, more transactions? Yeah. Withdraw. Let's withdraw 1,000. Bank says no. Current balance is still 500, right? They rejected that withdrawal. It looks like it's doing what it's supposed to be doing. So we're testing our code. We're making sure the code does what we expect it to do, right? With this sort of manual testing process. I know what it's supposed to do, so I'm going to give it a value and see if I get back what I'm expecting, right? That's how we test our code. We know what it's supposed to do, so if I give it a value, I should know what I should get back out when I'm done with it. That's the testing process. On Monday, we'll look at a better way to do that. And the better way is the computer. Computer is much better at that sort of thing. Just like when you write an English paper, it's really hard to spot your typos because you know what you meant. Honestly, it's really hard to find your bugs because you know what is supposed to come back out, and it's really easy to miss sometimes. And especially if you're doing it like 5, 6, 7, 8, 9, 10 times in a row, and you're debugging and it's not working, and then you're debugging and then it does work, and then you're debugging something else, and then you broke the first thing by mistake, but you didn't notice you broke the first thing by mistake. Right? The computer is much better at checking, did I get what I expected back out, than we are. So we'll look at how to do that on Monday. All right, so we've got some basic class examples. We're going to save the static stuff for Monday, and then we're going to save the testing for Monday as well. So come Monday, we'll talk about the Project 2 solution. That's relatively quick. Should take like half an hour or less. Don't feel bad if it takes you longer, right? I've been doing this for a long time, and I know how to solve it already in my head. Like, the hard part of programming is figuring out how to solve the problem step by step by step by step. The hard part, honestly, is not writing the code. Right? The hard part of programming is how do I take a hard, complex problem and break it down into simple enough steps that a stupid computer can do it. Right? If I know how to do that in English and I know what all the steps are, I've got a much better chance of being able to put it into code and translate it. It's this process. It's you call it pseudocode. It's kind of like code. You kind of sketch out, okay, this step, this step, this step, this step in as much broken English as you want. And then you can kind of check it and look through and, okay, is the process work? Do I have the right algorithm, right? Do I have the right steps to do it before you write the code? And you'll end up with a better product. All right, let me commit this to GitHub here. And then any thoughts, any questions, concerns? Are we in good shape? Cool. Anybody on Twitch? Mardell, you want to stay after for a minute? Yeah, I could definitely chat after. No big deal. So anybody who's remote, just ping me on Discord or send me a text, call me, email me. I can go from there. Oh, sorry. All right, so we'll commit this. This was classes part 1. And sorry for the late start. I really thought a 7:45 a.m. doctor's appointment would be fine for getting here by 10. That was wrong. We were the first person there for my son's appointment, but you know, okay, we had to wait. Yeah, yeah, and then we had to wait for the flu shot. Like, okay, we're here, might as well get the flu shot while we're here. And that took like 20 minutes to find someone to give him a flu shot because doctors are too busy to do that. So they had to, I don't know, get like the one aide who's running around the entire floor trying to help people. Yeah, it's a crazy system. Crazy system. All right, so let's go ahead and stop that. We had fun with our little looping here. All right, other thoughts, questions, concerns? If not, we'll call it a day. Work on project 2. Again, it's due Monday, 10 a.m. If you wait until Sunday and something's not working, I have very limited availability to help. I'm going to try because like I don't want to be a jerk and tell you to go away, but I can only like meet with you limited times, generally after my kids go to bed. So please, let's get it done before Sunday night is the goal, right? I mean, ideally before the weekend too, because I'd like to not have to do a bunch of stuff on the weekend. All right, you folks take care. I'll see you Monday.